of Chapter 2 deals with acceleration, speed, and velocity. The definition of acceleration is the rate of change of velocity. When the velocity of an object changes, the object is accelerating. And if you remember from Section 1, the definition of velocity is speed in a given direction. Change in velocity can be either a change in how fast something is moving or a change in the direction it is moving. So, acceleration occurs when an object changes its speed, its direction, or both. When you think of acceleration, you probably think of something speeding up. However, an object that is slowing down is also accelerating. Acceleration also has direction, just as velocity does. If the acceleration is in the same direction as the velocity, the speed increases and the acceleration is positive. This acceleration, as expressed in this diagram, is positive acceleration. If the speed decreases, and again, if the speed decreases, a key word here is decreases, the acceleration is in the opposite direction from the velocity, and the acceleration is negative. We also know this as deceleration. Again, it's not backing up. This car is still moving forward. It's moving in that direction, but because of this red light, it's slowing down. So the acceleration is negative. And during class, you'll hear me ask the question, if this person backs up, and he speeds up, then his acceleration is still positive, but when he slows down, the acceleration is negative. A change in velocity can be either a change in how fast something is moving or a change in the direction movement. Just like the example given of NASCAR track, that is a change in velocity because the direction is constantly changing. Same thing here, that a change in velocity or a change in acceleration can also occur because of the change in direction. Anytime a moving object changes direction, its velocity changes and it's accelerating. And here's another example. The speed of the horses in a carousel is constant. They can be going around. Think of a merry-go-round. Their speed is constant, but they're constantly changing direction. So the horses are accelerating because the direction is changing. To calculate acceleration of an object, the change in velocity is divided by the length of the time interval over which the change occurred. To calculate the change in velocity, subtract the initial velocity, the velocity at the beginning of the time interval, from the final velocity, the velocity at the end of the time interval. What this looks like then, the change in velocity is final velocity minus initial. And v sub f, final velocity minus initial velocity. Using this expression for the change in velocity, acceleration can be calculated from the following equation. Acceleration equals final velocity, expressed here, minus initial divided by time. And remember the units, meters per second squared. If the direction of motion doesn't change and the object moves in a straight line, the change in velocity is the same as the change in speed. Change velocity then is the final speed minus the initial speed. And remember that velocity, and what this says is that if it travels in a straight line in the same direction, then velocity and speed are the same thing, so that you can calculate it as the change, the final speed minus the initial speed. How is the acceleration for an object that's speeding up different from that of an object that is slowing down? And suppose a jetliner starts at rest at the end of a runway, reaches a speed of 80 meters per second in 20 seconds. The airliner is traveling in a straight line down a runway, so its speed and velocity are the same. Because it started from rest, its initial speed was 0. And its acceleration can be calculated as follows. The final velocity is 80 meters per second. minus the initial because it started at rest, divided by the time it took, 20 seconds. So acceleration then is 4 meters per second squared. Airliner is speeding up, so the final speed is greater than the initial speed and the acceleration is positive. And this graph expresses positive acceleration. Now notice that the variables are speed over time as opposed to what you saw in section 1 where you're solving for speed, you had distance over time. Now imagine that a skateboarder is moving in a straight line at a constant speed of 3 meters per second and comes to a stop in 2 seconds. The final speed is 0. He stops, and the initial speed was 3 meters per second. This equation's a little bit different. His acceleration then, his final velocity, is 0 because he stops. 0 minus his initial velocity of 3 meters per second divided by 20 seconds. And that's going to give you, and again, here our book editors missed it, it's going to be negative 1.5 meters per second squared. This should have a negative sign. Negative 1.5 meters per second squared. And this is negative velocity. Excuse me, negative acceleration. Skateboarder was traveling at, here he's at 3 meters per second. He slows down to a stop. So it's negative acceleration. Again, negative acceleration, the line slopes down. If it expressed like this, that would be positive acceleration. Acceleration always will be positive if an object is speeding up and negative if the object is slowing down. Again, I want to emphasize, doesn't mean if you're going backwards, that can still be positive acceleration. Engineers use the law of physics to design amusement park rides that are thrilling but harmless. The highest speeds and acceleration usually are produced on steel roller coasters. And we saw this in the video I showed you on Monday. Steel roller coasters can offer multiple steep drops and inversion loops which give the rider large accelerations. As the rider moves down a steep hill or an inversion loop, he'll gradually accelerate toward the ground due to gravity. Riders go around a sharp turn, they are also accelerated. This acceleration makes them feel as if a force is pushing them toward the side of the car. And that concludes the lecture notes for section 2. Again, I'm going to have you answer the questions that follow. Submit your answers in the assignment block to see that you did the lecture notes, and we'll give you credit for that. Acceleration is the rate of change of, okay, so answer that question. Question number 2, which is not a form of acceleration? Maintaining a constant speed and direction, speeding up, slowing down, or turning. Question 3, what's the acceleration of a hockey player who's skating at 10 meters per second and comes to a complete stop in 2 seconds? And I can tell you that this would be negative acceleration because he's slowing down, so it's not going to be answer A or answer C. Okay. And that concludes the questions for section 2, and section 3 will be posted again tomorrow.